Welcome everyone. Thank you for joining us for today's webinar. My name is Balassoubramanien and I am the Associate Professor at Department of Information Technology, Panimalar Engineering College, Chennai. Today we are presenting serverless architecture function as a service, presented by Mr. Shanemougham Balassoubramanien. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the chat box in your YouTube control panel. I will bring them up during the presentation, and we will also have time for questions at the end. We will post the attendance cum feedback form in the chat box at the end of the session. Based on that, each certificate will be issued to your registered email. Let us start the session with welcome note by our head of the department, Dr. M. Elda Mercy.
Good evening. On behalf of a Secretary and Correspondent, Most Honorable Dr. P. Chinnadura, MA, PhD, our Directors, Most Respected Tirumadi C. Vijay Rajeshwari, Thiru C. Saktikumar, ME, and Tirumadi Saranya Sri Saktikumar, B. MBA, and our Principal, Dr. K. Mani, I take it as a privilege to welcome each and every one of you to this webinar. Though the situation is frustrating, we all have a hope that the world was never shaken due to Spanish flu. Rather, the world has seen tremendous growth over 100 years. In the same way, after this COVID-19, we are also going to experience a marvelous growth. I really appreciate and welcome all the academicians, students, and people from various IT organizations that you have come forward to enhance your skill set amidst Lockdown 5.0. From the bottom of my heart, I welcome Mr. Shanemougham Balassoubramanien, APRA AMCOS Sydney, who has consented to share his knowledge and experience from Australia. It is almost 9:30 p.m. but still he has come forward to deliver his talk. We are very grateful and welcome you, sir. I welcome all the faculty members, and once again I welcome each and every one of you, and I'm sure this talk will definitely be beneficial to all. Now Professor Balasundara Ganapathy will take over the rest of the proceedings. Thank you.
Thank you. We will turn the time over to our presenter today. It's a great pleasure for me to introduce our expert speaker from Australia, Mr. Shanemougham Balassoubramanien. He has more than 18 years of experience in the information technology field. Currently, he is working as a business intelligence and analytics platform lead in the AMCOS, Sydney, Australia. Previously, he was working as a technical project manager and application development manager in HCL Australia Private Limited and the technical manager with HCL Technologies in India. He is an AWS certified solution architect and associate data scientist. In addition to this, he got various certifications like Exine Agile Scrum Master, Prince 2 Practitioner in Project Management from Agilo's Global Best Practice, Data Science Associate from Dell EMC, and Blockchain Essential Certification from IBM. He experienced in providing a solution, managing and delivering digital transformation projects, cloud migration, AWS, serverless architecture, cloud security, and business intelligence. He also has an extensive experience in technical management and hands-on AWS serverless services in Java. Without further ado, please join me in welcoming Mr. Shanemougham Balassoubramanien.
Hey Bala. Yeah. Yeah. Can you hear me, Bala? Well,
Yes, sir. Okay.
yeah. Okay.
Yeah, yes.
Thank you. Thanks, Bala. Thanks for the brief introduction. Thank you for this wonderful opportunity to share my knowledge with all the people. I'm very happy and excited about this session. You have given me a brief introduction, so I don't have to talk about myself. We will straight move to the presentation. So a few things before we get on. Most of the contents which I'm going to present primarily has taken from various documents and sessions I attended. So you can, it's all available on the internet. And please ask any questions if you have. I'll try to answer during the session or towards the end. If I can't able to answer any other question, I will come back through Bala. We can try to address your questions. Yeah, that's the context of the session now. Let's move on to the slide. The whole objective of this 1 hour, the next 1 hour, the primary objective, what I have in my mind, I want to, whoever's attending the session, I want to give them a glimpse of what is cloud computing and a view of what is serverless architecture, which is happening at this point of time, how it's coming up in the world, and why it's really required.
Sir,
Yeah.
Excuse me, sir.
Sorry.
I think there is a problem with YouTube. We will check and you can continue.
Okay. So shall I hold on?
Yes.
Yeah. Okay. I'm holding here. Thank you.
Sir, it's good only. You can continue the session. Hello. Hello.
Yeah. Yeah. Can you hear me now?
Sir, it's going good. Yeah, you can continue the session. It's going good.
Okay. Okay. Perfect. Thank you. Thanks, Bala. Yeah. So as I said earlier, I'm not sure how much we lost. Maybe I'll recap. For the agenda, I want to give for the next 1 hour primary objective of the session, I want to give a glimpse of what is cloud computing and what is serverless architecture which is coming up in the world now as a new. What is it about, why we need that, and some of the service offering given by various providers. And I'll show you a demo of what we have done in our organization now, and followed by questions. Yeah. All clear? Bala, is it clear, Bala? Yeah.
Yeah, it's clear.
Okay, now, fine. Cloud computing. Cloud computing, the description I had taken from Wiki. Cloud computing is the on-demand availability of computer system resources, especially data storage, computing power, without direct active management by user. So what it means, earlier, when I started my career, when I joined organization like HCL, any organization, let's say, it takes at least a week to get a computer where you actually start your work. So for us, we have seen that era, and for us now, you can get a computer much is more powerful in less than a minute. That's the most beauty of cloud computing. That's what the power of cloud computing is all about. Getting things on demand, getting things quicker, faster. And some of the history of the cloud, which is very interesting. The slides, if you can see here, it's in fact this idea is started in 1960s, kind of time sharing, where at that point of time mainframe used to be high cost, and a large organization can afford it. Smaller organization, they basically go and ask for 2 hours or 10 days and then complete their activity. So that's kind of no time sharing. That's a high level concept, and gradually 69, 70s things have been, the technology has been continuously evolving around in terms of the hardware, CPU, and network. All has been evolving constantly. In 1997, cloud computing is defined by the concept is defined by Professor Ramnath Chellappa. Post that, big thing started happening in 2006 when Amazon launched the EC2 and S3. That's a real kick started, right? So Amazon in 2006, what they did, they had a huge data center created for their Amazon services. This websites which we have now. So they said, since they had procured so much of hardware which is sitting ideal for some other time, so they decided to, like, mainframe time sharing. They started, can we do hardware as a service to the people? So that's a concept started, and then 2006 was a kickoff for them. And if you see 2006 to 2013, there is a huge gap in terms of the further adoption of cloud across the industry by organization. It's primarily driven by two dimensions. One, it was because people was not accepting the fact that we have to put the data in the different server. So data security was a big concern. Many of the organizations was not ready to support or I would say support. I mean, they're not ready or not trusting to move their data outside of the on-prem to the cloud. For the 10 years, so much of scenarios happened in terms of computers been evolving constantly. Security layers were being built, and which created trust on the cloud providers. So, for example, if you are a company if we have a company in Australia data will be residing within Australia. It will not go over. Such a promises has been started given by the cloud providers, and the adoption started. Now, in 2020, we know pretty much every organization is thinking about moving their application to the cloud. What cloud computing gives us? Some of the benefits we have, like disaster recovery, availability, scalability, automatic software updates, working from anywhere, which is very relevant for the context of the pandemic situation, what we are at this point of time, and security, and most importantly, cost effective. In terms of the disaster recovery, I would like to add a few points. In my experience, like 2005 or 6, 4 or 5, somewhere that year, I used to work in Chennai, where all the servers are on-prem, which will be in the office. Because of a huge rain and flooding, we were not able to enter we are unable to enter the office for 10 days, which created a huge problem within for the clients. There are losses for the client. For that situation, once we all come back to the normal, what we decided, we'll have a new disaster recovery center in Hyderabad. So we set up a complete new office, a similar office in Hyderabad, one in Chennai, exactly replicating all the data and content, so that if something happens in Chennai, we go to Hyderabad and vice versa. And that's one of the disaster recovery plan we provided in 2006. Now with this COVID and pandemic situation we have, we don't need to worry about a new location. All we need is a powerful system, and we have a sophisticated network. The data is available. Everybody works from, pretty much everybody in this place is working from home. So that's the benefit of adapting the cloud and enabling the software more virtualized has given us the power to the people, not necessarily to be in the office to work. More will be there with the current situation. Industry is very confident that many offices will be adapting more in terms of the cloud solutions. Yeah, that's the high-level history and very brief on cloud computing. I will move on to the next slide. So I listed on the left side some of the, over here, the top cloud providers: Amazon, of course, Microsoft Azure, Google Cloud Platform, IBM Cloud Services, Rackspace. There is Alibaba, Oracle. There are many cloud providers are on the market. If you see the right side, I have listed. Sorry. In the right side, I listed in terms of what is the product they provide, which organization like AWS, Azure, and GCP, virtual servers, platform as a service, serverless computing. How do they call it in AWS? For example, which virtual servers in AWS is called instances. Microsoft has a VMs and GCP as a VM instances. Similarly, platform. So I'm not going to talk in detail. I'll be sharing the slide to everyone. We can go in the serverless computing. We will go in detail. I'll explain further detail on Lambda. These are the high-level product and services being provided by the cloud providers. Let me move on to the So Bala, all clear? You are able to hear? Hello? Yes, yeah, fine. Okay, sorry. I'm just checking if things are able to working fine. So these are the fundamental offerings by major vendors, and they are building rapidly every day. Amazon and Azure are releasing so much of new services. Yeah, next slide. What I wanted to share on this slide, what is the service model given by the cloud providers, any cloud providers, right? If you see the left side, the service model, which is primarily called as IaaS, PaaS, and SaaS. IaaS is like in infrastructure as a service, PaaS is a platform as a service, SaaS is a software as a service. What's the difference is basically the responsibility on the layer of activity will be taking care. For example, in the IaaS, infrastructure as a service, all we do is that we get a bare metal, just a plain computer, which will be provisioned through the cloud. Our responsibility, if you see the right side, who is responsible? Vendor and customer. In this case, we are the customer. Once we get the bare metal, say I want a server of 32 GB RAM capacity, I want 2.5 gigahertz server, 2 terabyte of hard disk. Once we provide the specification, we get the bare metal. Anything on top of it, like installation of OS, managing the patch, installing the app server, everything goes back to the customer hand. That's the initial starting point of the cloud services. And then gradually they come up with a new idea of platform as a service, where we will request, I want a server with this capacity, I want a database to be installed, I want hardware has to be, I want a OS to be installed on Linux. Once you provide specification, we get that and they manage it. So once we get with that, and then they manage it. Okay, this is the PaaS level, platform as a service level, where we are getting a server with the OS already installed, a database which we require. The management of that goes back to the vendor. We don't have to worry about it. All we have to worry about is building the application on top of it. SaaS, software as a service. What's the difference between PaaS and SaaS is you get us in a software like Salesforce or a GoToMeeting or Teams. These are all the O365 email, Outlook. All these are all like a software service. You don't have to do anything. Basically, you get it, you configure, and you start working on that. You don't have to develop anything. In case of PaaS, you will be developing something. You will be developing your own application. Whereas SaaS, you get software as a service. Next slide, I'm going to talk detail of PaaS, functional service, which is very close to PaaS. This is the high level objective of the slide, like what is the core we'll be doing in terms of the functionality, and what is the responsibility of vendor and customer, and the left side is what kind of service model provided by the various service providers. Yeah, I'll move on to the next slide. So far, so good. Any major questions should be answered, Balassoubramanien? Okay. I'll continue further. Yeah, so thanks. Yeah. On this slide, what is serverless computing? Function as a service. Serverless is about maximizing the elasticity, cost saving, and agility. These are the three things, which is the most important one of the serverless concept. When you say serverless, it's not about there is no server. It's about there is server where our applications are working, but it does not rely on, it does not respond. The responsibility doesn't rely on us as a customer. It relies on the vendor. Our scope will be writing the functionality, deploying it, expect it works. All underlying layer will be taken care by the vendor. Function as a service, which is, these two are very tightly coupled. Serverless and FASS is tightly coupled. Function as a service is a category of cloud computing that provides a platform allowing a customer to develop, run, and manage applications without the complexity of building and maintain the infrastructure, typically developing and launching application. So that's the definition of FAS. What it means is, as a developer, I don't really have to worry about the underlying installation of Java or a Java server or IIS server or a .NET framework or Node.js, Linux. I don't have to really worry about it. My concern is I'll write the logic for that particular function and deploy it. That's the level of abstraction we are getting it, which is people like us developers, where we don't really worry on the nitty-gritties of setting up the environment, which is where we spend most of our time. That is completely avoided when we go to FAS as a functional service, which is FAS. So FAS, in terms of AWS, they call it called a Lambda. Like Microsoft Azure provides some Azure function, Google as a cloud function. So these are the three functional service provided by the major vendors. What are the pros? What is why do we need? What's the whole purpose of it? Pay as you go. So which means that if your function is, if you have installed your function in the server. In the normal PaaS or in a typical scenario, the server will be up and running, though there is no request. Say, for example, the function is supposed to do retrieve data or updating a data. Somebody has to request it to do the update, right? As long as no request is coming, this will be sitting idle in a typical scenarios. Whereas in FAS, what they do, this server will be shut down. And when there is a new trigger, it's all event based. When there is a trigger on the function, then the function comes back. It performs the service what is required. Either go back to get the data from the database or from the file storage and solve the problem. So it will not be up and running always. It will be up and running when it is required. That's why it's cheaper. That's why it's cost effective, and that's the called pay as you go. You just use it. If you're using for 20,000 record per day, you're just going to pay for the 20,000 record. That's the pay as you go. And as I said, like you don't have to worry too many things. You don't have to worry about installing of Java 1.8 or 1.11 or .NET Framework 4.5. All you have to mention is that I want to use my code requires 1.8. Rest all will be taken care by the underlying architecture of the AWS Lambda function or Azure function or a cloud function. And scalability, which is the another dimension of it. What it does, when there is a spike in the number of requests, if for example you have 100 requests coming at the same size, same time with concurrent users, there is a 100 Lambda function picks up automatically. You don't have to configure. As long as you set the max concurrent user as 100 concurrent user will be picked up, and then it will process, and it also goes back to the single. So in terms of scalable, we don't have to worry about any of the infrastructure. It will be taken care by the service providers. It's all good, but there are some limitations, I would say. Vendor lock-in. Because when we develop function, we have to develop with the interface provided by the AWS or Azure or Google. So what will happen is that in your source code, you will basically import SDK from the AWS. So your source code will be tightly coupled with that particular vendor. So moving away from the vendor will be challenging when we want to migrate from Google to Azure or AWS or AWS to Google in that case. So the migration time will be more, and then it's challenging. Also, it is unsuitable for a long-term task. This I'm saying. The whole selling point of the FAS is that it solves a problem and then it shuts down. If your function requires expected to be running for a longer time, you are not going to get the benefit of it, which means that your server is up and running for almost 24 hours, where you can get a cheaper EC2 for that. Also, Lambda function has a limitation of running for 15 minutes. If your function expects to be running more than 15 minutes, if your process is very high engine, like it has to decode a video recording file and produce artificial intelligence information or a huge reporting, that's not the right solution for the serverless. We can't go there. And cold start, that's another big concern. What is cold start is like when a Lambda function, if Lambda, as I mentioned earlier, Lambdas or any of the FAS is event based or trigger based. We will be setting up, if API calls, the server will, what will happen is that basically the server will start from the scratch, and then it will execute the function for you. So from the API request to the time it's going to bring up the machine is called cold start. I'll explain in detail about it in the upcoming slide, which is a big deal in terms of the latency. If your function requires low latency, Lambda function will not be a right solution. And similarly, it's a stateless. You can't expect a Lambda to have a state. It will not have any temporary data. So it will solve one request and it goes off. There is no session. Yeah, that's the high level on serverless and functional service. So let me move on to the next slide, which is what are the best use cases. One of the use cases FAS is, there are many, I just listed out two. In that, any user, if they want to consume a content or write a content to our, say it's a website, right, or a, any website where we are going to post the content. You hit the API gateway, read the content or write the content, just comes back. This read and write will be a function called at that point of time and then shut it down. If the number of users spans, this read content will be concurrently spanned, and then at the same time there is no request, nothing will be online, all will be shut down. And another classic example is like uploading a file. Say in your organization, every night there are 200 files will be given by the third party, which you have to process. Once a file deployed in the FTP server, Lambda function will trigger it. Basically, you can set up SNS or any other notification service. It will trigger the Lambda function, read the file, store it into S3, transform it, write it back to RDS. So this is a very classic problem. Many other Lambda functions will be used. Lambdas or fast as a service is stateless. It's event driven. It will be invoked based upon some action. And typically in the node, if you have to abstract all of the application what we do, there will be some event will be triggered either by a user or by a log or by a IO history, right? Yeah. Now, on this slide, I just wanted to list down what are the key, across the AWS, Azure, and Google, what are the kind of language they support. Lambda is more matured in terms of the number of languages supports than Azure and Google. Lambda supports like Node, Java, C#, Go, Python, Ruby, C++. It's evolving. Some of the pricing, I'm not going to go in detail. These are the key, I will say like metrics. When do you want to choose which, like Lambda, Azure or Google, these are the key metrics or measures you want to keep, like language support by third party, what is the kind of monitoring tool available, pricing, what is the limit. Say in this example, if you see Lambda will run for 15 minutes, that's a max limit any Lambda function can run. In case of Azure, there is no limitation of maximum run, but it allows only 10 concurrent execution per function. So these are trade-offs which you want to make out and then say, yeah, we can write in Lambda or we can go for Azure or GCP. Yeah. Moving on to the in terms of Lambda function. So we may be talking about like so we have been talking Lambda function as a serverless and it knows automatically, but it also has to be running on a server, right? So how does it work? We have to see how service providers would have been developed. So for example, event is coming from a database change or a API, it triggers it and then it consumes, go back to database, or this is basically which you expect the Lambda function to do. What happens when Lambda is being triggered? You see in the bottom slide, there are 4 steps as a ring. First step, once the request comes to the Lambda function, AWS service will try to identify the hardware, find the hardware, and create a container, right? On top of it, it will install the relevant language which we requested. It could be Java or Python or Go or whichever the runtime environment for that function, and deploy that function on top of it. So these 4 steps happens for every request, every new Lambda has been created. The moment it triggers, these are the 4 steps happens. And then once it serves the purpose, it shut it down. again, when a new request comes in, the whole process starts. Right? The core, I would say, like what else Lambda takes care. No, load balancing. We don't have to worry about if it's 1,000 requests coming in. How are you going to manage? They have the load balancer. It will automatically balance it. It will do auto scaling. It handles all the failures. If a Lambda is failing, the same request will be handled by a new Lambda. It's will be triggered, and then new Lambda will service them, return back the solution. So these are some of the core advantages of having Lambda function. The next one, this is like, so remember we talked about a cold start earlier. So what will happen? I just want to give the life cycle of if a Lambda has been triggered. In typical situation, even this is completely applicable for even a normal service what we do. Yeah, can you hear now? Hello, Bala, can you hear me? Hello. Yeah. Increase the volume. I don't know how to do that. Let me see. So it's set as a high level. Let me remove the headset. Yeah, Bala, is it better? Yeah, thank you. So the request life cycle. So if you see the flow, even forget about the Lambda, this will be the basic life cycle of any application starts. Your source code will be downloaded, and then you set up your environment. Then all your source code will run on the Java JVM or the .NET framework. Set the base, and then it will start serving the purpose. Right? If there's a request comes in, it starts serving. The only difference is that this part will be up and running forever. Once it's coming in a normal application environment, what we have, this will be continuously running. In case of Lambda, which is like this will shut down. So basically, this will shut down, and every time the same process will happen. Every time you download the source code, you set the container and bootstrap the runtime, and then start your code. So this is where the latency, the cold start, what we talked about, where it creates a latency for a new request. The other good part is that if the requests are coming continuously, and because we already have this bootstrapped up and running, you will hit only the warm start. So which is like where your start will be keep on will keep on running. How it happens is like AWS will keep on serving using the same instance as long as the request is coming. And once the request stops, then again it comes back with a new whole process. Yep. That's the internals of how a Lambda will be triggered and what are the process happens, steps involved in bringing up a Lambda, and what happens, why there will be a delay whenever there is a new Lambda function get triggered. There are ways to optimize. I'm not going to talk in detail. High level people, there are ways to overcome that, the cold start, but not fully. Yep, I'll move on to the next slide. So this is the source code, sample source code I just want to show, and then I'll jump onto the demo. See here, this is on the left side Java, and the right side is the by Python. Every invoke function happens on the handler. So in Java, we used to write static main method where that will be the hook for the hook for the JVM. Similarly, request handler is a hook for the Lambda function. And then internally, if you see here, you need to import the services, import the Java package on the request handler context, which will internally convert into Java static and then it processed to the JVM level. This is the reason we said, like, once we start building the serverless function, it will be hard to move away from one vendor to other vendor. Every vendor has their own package where you need to write, and then moving away from that will be a challenge. Yeah. And if you see the Python, we have to import the Boto3, then the handler function. This will be triggered every time. So that's what so far, in terms of the high level of what we have covered so far is like touch the cloud computing. We spoke about what are the key services being provided, service model. We went into the serverless architecture, why we need it, what is the advantage of that, what are the use cases of serverless, when not to use serverless, what are the pros and cons, and we have seen the internals of Lambda function and the sample source code. Now I'll be showing a quick demo on what we created in the Lambda function. So this demo, the purpose of this demo, create an API for third party. Say, for example, our organization wants to expose an API for a third party where he can read member data or he can read data from our database. What will be the usual steps? The steps are like, create an API. You need to have a API which will be exposed, and then you need to have a function which will connect database and insert, update, or get, and database to create a schema, right? These are the typical steps we'll be doing. If it is not a Lambda, what would have happened is that we will be having two servers. We will be setting up a two server, one as an API server, where we need to have a load balancer, and then set up the API engine. Then we'll have a function. The function will probably we need to have a Java server set up. Yep, and then database. Right, these will be the typical situations, typical activities we'll be doing if there is no Lambda. Whereas in Lambda, you write one Lambda function, and API will be created automatically with a single click. Right, I'll show you now what how it has been achieved. Just a minute. Yeah, so it's coming up. Meanwhile, I'll just quickly show, I know, template.yaml. So there's one important function called cloud formation, right? Cloud formation concept is that you develop source code basically to create infrastructure. It's called infrastructure as a code. That's their key motto. So what I have done is that I created a lambda function. It's called Spring Cloud function. And these are the configurations you require to set up. There are two ways to do. One through the YAML file, through the cloud formation, and through the console. I'll show the console as well. I'm just showing the easiest way to do that, and it is the industry to any of the development will be happening through this cloud formation. Okay, once we run this one, what happens is that it creates API gateway. This API gateway is automatically this is one of the service by the AWS. API gateway manages load balancing. It install your API and connect to the Lambda function. It takes care of the heavy lifting, right? Yeah, if you see here, this is the Lambda function which we there's an API which got created, and this is a Lambda function. So when we have to set up on one single click, it comes out and say what kind of method request and what is the integration request and where you want to hit. Here the hit is the query executor, which is a Lambda function, and then it goes back response out. We will do the testing later. I'll show the query executor Lambda function, and then I'll come back to this console. So to go to Lambda, we basically not generally go to AWS service. I hope everybody has the AWS service. I've been gone to the screen. If not, no, it's free. You can use most of the critical services for free. There are a lot of free tiers, and you can register it and then start working on it. And then once you logged in, you land in this page. We'll play Lambda. If you don't create it, this will be a blank, and I will be search for my Lambda function. Query executor.
Hello, Shanemougham.
Yeah.
Sir, I'm Bala.
Yes.
Can you wait for a few minutes? I would check the audio connection here.
Okay, fine. Yeah.
Hello? Hello? Hello, sir?
Yes.
Hello, now you can proceed, sir.
Okay.
I think there is a disturbance in the audio. Can check your headset also, headset and mic.
Yeah, I just checked it. Is it clear now? Is it okay? I still have a problem.
Voice sometime it's coming and sometime it's lagging. Can you have another headset?
let me try with this approach. See. Bala, is it okay now? Is it clear or you still have problem?
Yeah, it's okay, sir. When you are explaining the concept, somewhat the voice is not audible and it's not clear. But when you are speaking to someone else, it's good.
I don't know.
Okay, now you can proceed anyhow.
Okay. No worries. Yeah, so where we left, we started with the Lambda, entering into the Lambda. So once you logged in, you basically search for the Lambda service and then you land on this page. This is the query executor function which I created for this demo purpose. If you see here, these are the triggers what I spoke about. The Lambda is all about trigger. So the trigger I set here is the API gateway. And you can add more triggers like IoT, Alexa can trigger the Lambda and S3 bucket. So if a file is stored in the S3 bucket, which is a storage for AWS, once it's loaded in the file, that file, once you load the file will trigger this Lambda. So you can add, there are so many triggering mechanism to the Lambda function. So went out. Sorry, went out. I'm going back again. Yeah. So this is the starting, and then you can have a destination by it can go back to the S3 or database. However, you can achieve through your source code as well. And this is the source code what we have loaded, and some of the variables or keys. Most importantly, this is the basic setting. If you see here, we have set it up as a query executor dot query execute handler request. You remember the file I showed you where our Java file request handler. This is the main file which we have created and it will be triggered. And we have set as in the memory RAM size as a 512. And my runtime is Java 11 and basic descriptions and timeout 30 seconds. Basically, it times out after 30 seconds. This is the key settings for any new Lambda function we create. And these are all some of the security groups and subnets. And this is the concurrency I spoke about. You can say, I want to reserve saying like 500 concurrency, I can do that for this Lambda function. So you can say 500, which means that there'll be 500 Lambda will be triggered at any given point of time. So which we don't need now. I'm just saying there are functions which has to be just heavily used. There are a lot of users where they require high amount of 100 or 50 concurrent users. And these are additional variables which are slightly in depth. And permissions, what kind of permission you have. So this has a permission to other services or which we have to reach out. And monitoring. So this is another wonderful feature provided by the AWS, where you can measure how many times a Lambda has been invoked, what is the duration the Lambda has been executed, what is the error count, throttling, which is struck. So many dashboards which gives us the insight of how the Lambda function is being used. And is there a way to optimize, or if there is no requirement, we are good. Right? The dead letters is like how many times we are having our Lambda service is getting failed. These are the high-level configurations when we create any new Lambda function. Some of the basics like loading the file and setting the trigger. These are all the very common settings required to deploy. So this is what we will be doing. You develop a source code, you upload the source code here, and set up the basic configuration. That's all. You're not worried about whether we have to install Java or JBoss. It's all taken care by AWS. All we have to focus is on the code, on the logic of the source code, what we create. And as we mentioned, we are created to have a API gateway, right? We are exposing our database through API, where the Lambda function will serve as a content provider. We'll do a basic test. So, we'll say so. Before we go there, we see here this is a client. Basically, this could be a web app or a mobile app or any of the app. This is a test feature driven by the API gateway to test whether our API and Lambda is working fine. Otherwise, this is the same request or the same request you expect any third party to send to you. And I'm saying I want the data. So this is the request type, which is being JSON. And I say this is a query string. This is a query I want. Basically, I'm saying get me the top 100 from the mem table. There is a mem table in the database, and say I want this data. So this is the data being concerned or required by the third party. So imagine you have a mobile phone, or you are working on an organization where you need this data for your review purpose. You say, I want this data through your web application, and it comes to the API. API triggers a Lambda. Lambda goes to database, and the response goes back. So this is a test. I'm saying this simulated as like, yes, request is coming from third party, and this will be the response going back to the third party. So if you see how easy to deploy a function and expect it to run automatically. If it is not Lambda, we would have spent time on installing the necessary prerequisite software, like starting from the Linux, and then you would have installed your JVM, would have installed the JBoss, and then you would have set up an API gateway server, then connecting the API gateway to the Lambda. All the nitty-gritties, all this kind of connection point has been taken care. The heavy lift, which is not really required, has been taken care by the providers. And as a developer, we need to focus on the logic, write it, deploy it, and release to the prod. That's the most simple or most abstract level what they're trying to do. That's all on the demo side, and we have 3 more minutes. We can go on the questions if we have. So just to recap, as we started initially, we want to give a brief intro to cloud computing. We've done that. We moved to the service model. We moved to the focused on the serverless architecture, why we need and what are the pros and cons. Then we stepped on to the Lambda function, how the Lambda is being implemented internally, how we do that. And then we went to a quick demo, how quick we can develop and deploy a source code to the production and release it. Okay, the question is, how far is the serverless method secure? If you good questions, let me go back here, right? the serverless, any serverless function which will be running inside the VPC or the subnet. So which means that this hardware is provisioned within the virtual private cloud, which is designed, which is allotted for the organization. For example, for my company, we have a couple of VPCs running, which is fully secured. Only our network can able to talk to the VPC. It's like running any of the EC2 instance or any of other services which we are trying to use from the security perspective, right? And then there are security groups we provide, say, who can reach out. It's not going to run on outside of VPC. It will be on within the VPC. And what are the disadvantages? As I mentioned earlier, there is disadvantages, I would say. There are limitations, I would say, more than the disadvantage. Where once you develop a Lambda function in AWS, if you don't want to continue with AWS, you want to move away from AWS, it's going to take time. You need to rewrite the whole logic for different cloud providers. That's a huge limitation and disadvantage I would consider. And the other most important point was the cold start, right? As I mentioned, because every Lambda function invoked at that point of time of the request when the request is required, either through a API or through a S3 trigger or a SNS trigger, there is a latency. Say the latency could be like 1 second or 2 seconds, depends on the heavy method you have in your function. Maximum could be like 3 seconds, right? But there are applications where the latency expected less than milliseconds. They can't go even seconds. They expect less than a milliseconds. In those cases, you cannot use Lambda. How does the provider gain trust from the companies? So there are reports produced by the companies saying what are the audit history being done frequently, every 3 minutes, every 3 months. There are frequencies varies, depends on the organization. They do the report of how secure the environment. They do the DDoS testing. They do the penetration testing. They do the continuous testing and keep providing the reports to the organization. It's all being published, right? That's how they build the confidence, saying that the environment is solid and nobody can penetrate. That's how they're building the trust. And other dimension is that for Australia-based organizations, all the data will reside within Australia. There'll be multiple ACs, multiple data centers, so that it's been replicated, and then there is during the disaster recovery, we can still able to take out the data. However, if we insist that the data has to be within Australia, they will ensure it's going to be within Australia. So these are the way, depends on the company's requirement, they provide the support and ensure we believe the providers. Other question, how does the serverless system help a developer? Then downloading a source code, how does the serverless system? Downloading a source code. So the question is like, how does the serverless system help developer other than downloading a source code? Okay. In terms of it's not downloading a source code. How I see is that it helps a developer to not worry about any of the nitty-gritties of how do you install and if you have to upgrade to Java 11 from Java 1.8 to 11, you don't have to worry about it. You have to reconfigure it and then deploy your application. So that's the kind of flexibility which we will have it. Yep. Any more questions?
I think This is enough for this session.
No problem, Bala. I think I'm not sure the level I've taken. I hope it's all clear, or whatever I want to convey, conveyed. Any other questions, we can reach out to my email or through you. I can respond back.
Audience can post their feedback with the link which is shown in your YouTube chat panel.
Yeah. So I think, Bala, is it all? We can
Wait
the call.
a minute. Please,
Yeah,
wait
sure,
a minute.
sorry. Yeah.
Yeah. And, I want to give a lot of thanks. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of the Panimalar Engineering College Department of Information Technology, extend a very hearty vote of thanks to the honorable delegates who blessed us with their presence and took out valuable time of your busy schedule. I must mention our deep sense of appreciation for Mr. Shanemougham Balassoubramanien for his work. I especially liked Mr. Shanemougham Balassoubramanen's speech where he mentions serverless architecture and its implementation. The way he explained the topic is exemplary. I also wish to express my gratitude to our secretary and correspondent, Dr. P. Chennai, MA, PhD, our dynamic director, Mr. C. Saktikumar, ME, and our principal, Dr. K. Bari, ME, PhD, for providing encouragement and support. I am very grateful to Dr. M. Helda Mercy, head of the Department of IT, for giving us an opportunity to organize this event. Last but not least, I thank you all the participants for showing their interest in the program and their continuous support. I once again thank you very much for attending this session. And the feedback link I will do post right for a minute. Participants, please share your feedback. In this link, https://url.com YACH 2PJ5. Okay, you can also use the QR code to scan and send your feedback.